So I'll give it till 2:32 before I start. So.
All right, now I got 10.
So yeah, we heard you.
I need to turn the sound off.
Not necessarily, not unless you can have background noise. I mean, you could just, it's fine. Okay. So let me just show you guys. I'm going to put up the die simulation. I'm going to kind of talk y'all through it because I had some questions pertaining to that from some of my students. So that's what I'm going to do now. Can everybody see that? So this is the die simulation from yesterday. It says, and I'm just going to go over this really quickly to just orient you guys on what the expectation was yesterday with regard to this activity, okay? So it says sometimes in real life we cannot find the actual probability that an event occurs, so we use a process called simulation with technology to estimate what the true probability of an event equals. Some examples include the chance that it would rain or snow, having a car accident, getting a coronavirus, or if a store will have toilet paper, things that we're dealing with right now, yeah. You'll need a pair of dice that can be found in many games. If you do not have a pair of dice, then they provided a link on here. Do y'all see this link right here? So that was provided. Now, I actually have some dice. So when I did this activity, I rolled the dice. It says first, decide what you think the sum of your dice will equal when you roll a pair of dice. So basically here, you're just going to circle a number, whichever number you like. So I'm going to circle 6 on here because I like 6, okay? Then when it says roll your pair of dice 6 times and record the sum. Now, again, you could have used this up here to roll the dice if you didn't have any dice at your house, but I'm going to go ahead and roll a pair of dice, and I'm going to roll it 6 times. So the first time when I rolled the dice, I got 11. So I've got 5 plus 6, that equals 11. I'm going to roll it again. That time I got 3 plus 8, or 3 plus 5, sorry, that equals 8. And then third time, 2 and 4. 2 plus 4, that equals 6. So that time I did get the number that I chose, the combination I chose, the sum of the 2 dice. So this time I got 3 and 1. 3 plus 1, that equals 4. Then I got 3 and 6. That equals 9. And my last one, I got 6 and 4. 6 plus 4, that equals 10. So it says, how many times did the sum you picked occur? So I chose the sum of 6, and I only got that one time. So I got 11 here, 8, 6, 4, 9, 10. Notice I didn't get the same thing even more than once. I got everything just one time. So hang on one second. Somebody's waiting. So I don't like this admit thing that I have to do now. All right. So so basically, how many times did the sum you picked occur? It occurred one time. We chose 6 up here when I added my 2 dice down here. I don't think you guys can see that 11. When I only got this one right here where I added them together and they equaled 6. So it says divide the amount of times your sum occurred by 6. We rolled the dice 6 times. My sum occurred 1 time. So that would have been 1 out of 6. I could turn that into a decimal. 1 divided by 6 is equal to 0.17 because it's 6666. And if we multiply that by 100, that would be 17%. So those are the different ways that we could represent this. All right, so then the next thing down here says the theoretical probability of the proportion of times you would get the number you chose is a very long series of repetitions of rolling the dice. What is the actual or theoretical probability of getting the number you picked? So in this case, we have the numbers 1 through 12 up here. Well, when I rolled 2 dice, I have 1 through 6 that could show up on that blue dice right there, 1 through 6 on the blue dice, and I have 1 through 6 that could show up on the red dice. So when I start talking about how many potential outcomes could I have, it would have been 36 because I could have got 1 on the first dice and then 2, 3, 4, 5, 6. I could have got 2 and again 3, 4, 5, 6. So let me admit some more of these people. Y'all hold on one second. I got a whole bunch of people kind of hanging out there and I'm going to let them in. Okay, guys, so what I'm doing right now, for those of you that just joined us, is I am going over the dice simulation that we did yesterday so that you guys understand what's going on. If you guys keep your mics muted unless you have a question, that would be great. But for now, I'm just going to continue through this. So we chose up here, we chose whatever combination we wanted. We went ahead and rolled the dice 6 times, and then we only got 6 one of those times when we talked about the sum of the 2 dice, or 2 dice. So then it says divide that. Lana, is that you? Somebody was really loud there. Okay, so then it says, what is the actual theoretical probability of getting the number you pick? So we have a potential of 36 outcomes. So that's really important for you guys to know. And again, that's because I could have rolled 1 on one of the dice and 1 through 6 on the other, and then 2 and 3 and 4 and 5. And I'm going to show you guys that on a chart in just a second. So then it says, what is the actual theoretical probability of getting the number you pick? So in this case, we're talking about 6. So if we were talking about 6, then we have a variety of different combinations that we could have got. Now, this would have been, we got the theoretical probability of, so what is the actual theoretical probability of getting the number you picked? It would have been what? Basically, if I rolled the dice 1, 2, 3, 4, 5, 6 times, and 6 was the one option out of 12, then what would that have been? That would have been 1 out of 12, right, guys? Y'all understand? So the actual theoretical probability, whereas this, we could have rolled 6. Let's talk about what that is. So the ways I could get 6 are 2, let's just do 1 plus 5 and 5 plus 1, 2 plus 4 and 4 plus 2, and 3 plus 3. So how many outcomes is that? That's 5 outcomes, right? Because if I go higher, if I go 6, anything I add to 6 is going to be greater than 6, right? So we wouldn't choose that one, okay? So these were 5 outcomes. So it says, what is the actual theoretical probability of getting the number you picked? 5 out of 36 outcomes. Does everybody understand how I got the 5 out of 36?
I didn't see it.
You didn't see what?
No, I didn't get to see the part. I left and I came back.
Well, that's on you, girl. Anyway, let's talk about this again then. Okay, so down here, how many possible outcomes are there? There's 6 by 6, right, guys? Because we got 1, 2, 3, 4, 5, 6. That's what we could roll on the first dice, right? Then on the second dice, we could roll, again, what could we roll over here? We could roll a 1, right?
Mm-hmm.
That would be 1 by 1, right? And then we could roll 2. So when we start talking through this, let me just show you guys here. Let me see if I can find it. I was looking for it earlier, but basically when we talk about this grid, guys, it's going to go like this, right? So our outcomes of the dice are going to go across 2, 3, 4, 5, and 6, right? So we could have a 2 and a 2. We could have a 1 and a 1. So that's what we got to think of when we start thinking of this. So it's going to go 6 across this way, and it's going to go 6 across this way. So our potential outcomes are 36, okay? So then it says, how close did you get to the actual theoretical probability? Well, we had 5 out of 36, but we got 1 out of 36. Well, honestly, that's pretty close. So if you guys compare 5 out of 36 to 1 out of 36, or sorry, 1 out of 6, well, 6 out of 36 is 1 out of 6, isn't it, guys?
Mm-hmm.
So it's pretty close. They're not equal. They're definitely not equal, but they're pretty close to each other because, again, remember, 6 out of 36 is equal. I don't know if y'all can see this. Let me pull this up a little bit. 6 out of 36 is equal to 1 out of 6, right? And so we were pretty close, okay? Then on the back page, this is the second part of the activity, okay? So when we did this, what it said to do here was go ahead and roll your dice, okay? So again, if you had dice, you could have just done this with your dice and then record what you got for your sum. So when I roll the dice here, I got 4 plus 4, that's 8, right? So I would have put 8 here, keep rolling it, 3. Y'all follow me here?
Mm-hmm.
Again, I got 8. Y'all following? So that would do that for this whole chart. Okay, now, again, the number, how many times did the sum you picked occur? So chances are when you did this way, the 6 would have occurred more frequently than it did here. However, even here, it appeared 1 time. Y'all got that? So what we're expecting to happen. So let's just say that it did occur 5 out of 36 times, which is not likely, y'all. I mean, you're probably going to get 4 out of 36 or 7 out of 36, but if it actually it appeared 5 times out of the 50 times. So how many times did it appear? So let's just say it appeared 5 times. Let me scratch through this because that's what it says, okay? Then it says divide the amount you occurred by 50, right? So this time it would have been 5 out of 50, and that would have been 1/10. Y'all see that? Whereas because I rolled the dice 50 times here, y'all following? Whereas if maybe it showed up 10 times, then that would have been 10 out of 50, and that would have been what? 1/5. Y'all following? So that's how you get this number right here. Then it says, how close did you get to the actual or theoretical probability this time? Well, we all know our theoretical probability back here was what? 5 out of 36, right? So the real question is, how close were you to that when you did this on the second page? And then it says, is it closer when you rolled with 6 rolls? And the answer to that could be yes or no, but it should be yes, because the more times you roll the dice, the more likely you are to get closer to the theoretical probability, okay? And then, so that's what the question was, okay? Do y'all have any other questions about this activity that you guys did yesterday? Anybody?
No.
Okay. All right, so I'm going to jump into today's notes. Okay, so this is today's notes. Anybody have any questions on this stuff? So do you guys understand the difference between theoretical and experimental probability?
Yep.
Is there anybody that doesn't understand the difference between theoretical and experimental probability? Anybody not understand the difference between theoretical and experimental probability?
Ms. Jones,
Yes.
I understand the difference, but I just want to learn more about the experimental one.
Okay, so let's just talk about each of them first, okay? So it says here, blank is the measure of how likely an event is to occur. That's the probability, right, guys?
Mm-hmm.
And then it says each possible result of probability experiment or a situation is an outcome, okay? The blank is the set of all possible outcomes. I don't know who's got a bunch of noise in the background, y'all. You guys need to mute it. Okay, there we go. That's better. So basically, as we work through this, experimental probability has to do with when you actually do an experiment, how many times you do it. Like what we did yesterday with that dice simulation, when we actually rolled the dice the 50 times, that was an experiment. Versus what we expected to happen, which is the theoretical probability. Okay, guys, do y'all understand the difference now?
Yes.
Okay, so so I'm going to go ahead and work through this. Let me go ahead and pull this up on our, give me a second, guys. I'm going to put this up on my board for you guys to see. Okay. PowerPoint, so little one. We'll see how good this is going to work or not, y'all. So we'll try. We'll switch back and forth if we need to. But I'm going to go ahead and put the board up. Okay, so maybe if I can figure out how to do this. Hold on a sec, guys. I got to put the slide up. So share the screen. Here we are. All right. Can anybody see that?
Yes.
Okay, so this is, I'm going to see if I can shrink this down somehow. Maybe, maybe not. It's not going to cooperate with me. Of course. Okay, so let's just try it this way. Can everybody still see this?
Mm-hmm.
Okay, so this is, it says the probability is a measure of how likely an event is to occur. Each possible result of the probability experiment situation is called an outcome. The sample space is a set of all possible outcomes. So like if we're to flip a dice, all our possible 1 dice, our possible outcomes would be 1 through 6, right, guys?
Yes.
Okay, so it says, so here, that's what this has to do with. So if we roll one numbered cube that's numbered 1 through 6, our sample space is 1, 2, 3, 4, 5, 6, right?
Mm-hmm.
If we were to spin the spinner here, our possible outcomes would be what? These 4 colors. So it's like this. Can you guys see that?
Yes.
The spinner. So every one of those, when I spin that is an outcome, right? So I could get red or blue or green or yellow, okay? Those are our outcomes. So when we talk about probabilities, there's a couple different ways we can express them. We can express them as a number from 0 to 1. That means it's a decimal, right? Or as a percent from 0, or as a fraction, okay? So for example, when things are absolutely impossible is obviously 0%. If we know for sure something's going to happen, that's 100%. And we're talking about in here somewhere, you know, in the midst of it. So if we are halfway between 0 and impossible, basically, and certain, that's 50%, right? So there's 3 different ways to express that: as a decimal, as a fraction, and as a percentage. Does everybody know how to get this decimal to the percentage?
Yes.
Okay, so we just multiply that by 100, right, y'all?
Mm-hmm.
Okay, so basically, when we're talking about theoretical probability, we're talking about things that are equally likely outcomes, okay? So our favorable outcomes have to do with what are we looking for? What do we, like if we want to, how many times can we get a red on here, like it is here over here, y'all? How many times can we get red if we spin it? Follow what I'm saying? So basically, there's 4 potential outcomes here, right, y'all? And how many of those 4 are red? That's not a trick question, y'all. I got 4 outcomes, right? Can y'all see this, what I'm showing you right here?
Mm-hmm.
Okay, so I got yellow, green, blue, and red, right? So there's 4 possible outcomes, but only one of them is red, right? So that's what we're talking about here. So if we were talking about red out of the 4, that would be 1 out of 4. Y'all understand?
Yes.
And that's theoretical probability. Well, now, when we start talking about experimental probability, it's when we start spinning that thing and seeing if we spun it 100 times, how many of those 100 times would it actually fall on red? We would expect that it would fall on there 25 out of the 100 because that's equal to 1/4, but that may not be the case, okay? So we're going to go ahead and talk to this first example. It says, find the theoretical probability. Each letter of the word probable is written on a separate card. The cards are placed face down and mixed up. What is the probability that a randomly selected card has a consonant? Okay, so first question for y'all is, how many letters are in the word probable?
There's 8.
So we got, yeah, let's just count 1, 2, 3, 4, 5, 6, 7, 8, right, y'all?
Yeah.
And then it says, what is the probability that I randomly select a card that's a consonant? Now, I know y'all all know what vowels are, but sometimes people forget what consonants are. They're basically anything that's not a vowel, right? So our vowels are O, A, and E, right, y'all?
Mm-hmm.
So we've got P, R, B, B, and L. So there are 8 possible outcomes, and there are 5 favorable outcomes because that's the number of consonants. So all we're going to do is put the 5 over the 8. That's it. And that's, if we were to do this and get a decimal, it would be 0.625, right? And then we multiply that by 100 to get our percentage. So anybody have any questions?
No.
Okay. So then this is what we're talking about rolling those dice now. Do y'all see this right here, this chart? This is a really good example. So if we were to roll 1, 2, 3, 4, 5, 6 with our red die, and then just all ones with our blue die, y'all see that? Those are 6 possible outcomes, right? Here's another 6 possible outcomes. When we roll a 2 with the blue die, but we have 1 through 6 with the red die. And y'all see how this keeps going? These are all the possible outcomes. So if we went from left to right here, we would have 6. And if we went top to bottom, we have 6. And 6 times 6 is 36. So anytime, you guys, you roll 2 dice, you're going to have a possible outcomes of 36, okay? Then this says 2 number cubes are rolled. What is the probability that the difference between the 2 numbers is 4? So what does that word difference mean, y'all? Anybody tell me, what does difference mean? Okay, so don't tell me. It means subtraction, doesn't it, guys? Okay, so when we subtract these numbers, if we subtract 1 from 1, we get what? 0, right? 1 from 2, that's going to be 1. 1 from 3, that's 2. 1 from 4, that's 3. This one right here, 5 from 1. So we could circle this outcome. Y'all see what I'm saying?
Mm-hmm.
We could circle this outcome. And then we also got this 2 from 6, right? That would also be 4. Is there anything in this column when we subtract them that's going to give us the number 4, y'all? in this column right here? I don't see anything.
No.
Okay. See, then over here again, do we have anything here? So 5 from 4, 4 from 4, nope. 1 from 5, up. Look at this one right here. Y'all see this one over here?
Yes.
When I subtract 1 from 5, I get 4 again, don't I?
Mm-hmm.
Okay. So the only ones I see are 6 and 2. And let's see if I'm right. So there are 36. So there were 4, it's saying. So we got 5 and 1 here, 1 and 5 there. We got 6 and 2 here. And where's the other one? I'm trying to find it. Y'all see it? 3, 6, 3. That's 3. 1 and 4. Oh, that was 3. 1, 2, 3. So that's 4. Okay. So 4 outcomes: 1 and 5, 2 and 6, 5 and 1, and 6 and 2. That was the one I was missing. Okay. So those are the 4 possible outcomes. So then what do we do with that 4? We put it over what? We put it over the 6. Y'all see it? So we put the 4 over the the 4 over the 36. I meant to say 36. And then we reduce it. So again, remember this, if we divide this 1 into this 9, this could be a decimal. This could be, we could leave it as a fraction, as a simplified fraction, or we can put it as a percentage. So if we divide 1 into 9, we get 0.11, and that would be 11%, okay? Or 11.1% if we want to be really accurate, okay? So I'm not going to go over the check it outs with y'all, but I am going to jump into example 2. So I'm going to go ahead and go forward here with you guys and show you. So this one, then the next thing that we're going to talk about are complements. So basically the complement is when something doesn't happen, okay? So on the bottom of y'all's page of notes, it says the sum of all probabilities of sample space is 1. So the complement of an event is the set of all outcomes in the sample space that are not E. So let's say, in this example over here, if I said, what is the probability that I don't land on red, it would be 3 out of 4, right? Because I got 3 other colors besides the red, okay? So that's what the complement means. And the way we represent that is by putting a prime next to whatever it says, okay? So it says the probability of a complement of an event E is the probability that it's not E. So we're going to subtract the probability of E from 1. So like in this example over here, again, we have 1 color out of 4, right? So what's the probability that I don't get red? It's going to be 3 out of 4. So I would subtract 1 out of 4 from 3 out of 1 out of 4 from 4 out of 4, and that's 3 out of 4. Okay. So here, let's talk about this example. It says there are 25 students in a study hall. The table shows the number of students who are studying foreign language. What is the probability that a randomly selected student is not studying a foreign language? Okay, so on this one, so we got to count up how many kids are taking a foreign language. So that's 6 plus 12, that's 18, plus 3, that's 21. So out of the 25 students, 21 of them are taking a foreign language. So how many aren't? That's what we're going to talk about. So we're going to subtract 21 out of over 25 from the 1, and that's going to, and I always make this an improper fraction, y'all. So I make this 25 over 25 minus 21 over 25, and that would give us 4 out of 25. Now, if y'all have a calculator, you can do this right in your handy dandy little calculator. Again, dividing that 4 by the 25, and that gives you 16%, 0.16 or 16%, okay? All right, so you guys would go ahead and do the check it outs. And now this is where we're talking about experimental probability versus theoretical probability, okay? So when it talks about experimental probability, it means that this time we're going to do something a number of times, and we're going to determine if that event actually occurred. So it says you can estimate the probability of an event by using data or by experimenting. For example, if a doctor states the operation has an 80% probability of success, its estimated probability is based on similar cases. So basically, how many times was the surgery done? This is what they think is going to happen, but when we actually do the surgery, that would be the experimental probability, okay? So when we do the experiment, that's what's going to determine whether it actually comes out to be what we expected it to be or not, okay? So oftentimes they use experiments with large numbers to come out with these probabilities. So what's the probability of your success in a surgery? that is based on how many times the surgery was done successfully. Okay, so let's talk about this example here. It says find the experimental probability. The table shows the results of a spinner experiment. Find the experimental probability. So this time, instead of having one like this, it would have the numbers 1, 2, 3, 4 on it, right? So when they actually spun it, they got the 1 6 times, and they got the 2 11 times, and the 3 19 times, and the 4 14 times. Okay, so the very first thing we would want to do is add up the number of times that they got. That was 50 times, right? And how many times did they get the 4? They got it 14 times out of the 50 times. So when we do this, we're going to divide the 14 by the 50. We're going to always write these in reduced form. So if it's a fraction, you want to make sure you reduce that fraction. And if we divided 7 by 25, we would get 0.28, which is 28%. Does everybody understand? Okay. So now this time it says the table shows the results of the spinner. We didn't change the table, but this time it says spinning a number that's greater than 2. So that would mean we would be then counting all the outcomes here for 3 and for 4. So we would add the 19 to the 4, right? I'm sorry, so the 19 to the 14. And that would be 33. And then we're talking about, again, it was rolled 50, it was spun 50 times. So that's going to be 0.66 when we divide the 33 by the 50, and we multiply that by 100 to get the percentage. So that's 66%. Okay. So do you guys have any questions? Anybody?
No.
Okay. Do you understand a little bit better now?
Yeah.
Okay. Well, if you have any other questions, you can shoot them to your teacher or to me, whichever is the case, you know. So, because I pretty much went through. Did you have any questions on the dice simulation, the thing we did yesterday?
No.
Okay. All right. Well, hopefully you're good to go. The homework for this lesson is going to be up there tomorrow. Some teachers may have already put it up there. I did. I put it up there for my kids. It's just under tomorrow. So you can answer that homework 2 different ways. You can do it online. There's a quiz way to basically go in and put your answers in, or you can print it like we did, like I did this, and fill it out, or write it on a sheet of paper and put it in under the assignments in the Dropbox. Okay?
Okay.
All right. Well, you have a good day.
Thank you. You too.
You're welcome. Bye-bye.
Bye.